Alright, the next Unit 2, contingency table. Now, the contingency table we use as a contingency table to help with calculating probability. It develops probability based on two events. Now, the good thing about a contingency table, is that you don't need a lot of information. You could figure out a contingency table by just minimal amount of information. Okay, here's an example of what would be a contingency table, what you could use. A popular band held at a concert at a local bar. 65 male fans and 89 female fans attended. 33 males were underage and 46 females are underage entering the bar. Build a data and calculate that a randomly selected fan would A. not get ID'd upon arrival, B. was a female that required ID, and C. if it's a male and it's known that he got ID. If you look at the question here, I put a line over the bottom ID to show that people that did not get ID'd. Now in the question it says that 33 males got ID'd and there's a total of 65 males. Now that's just simple math, and all you have to do is add the other number, and that's 32, which equals 65. 33 plus 32 is 65. Simple math. The next one is 46 females were ID'd and there's a total of 89 females. If you look at it again, simple math, just adding. The number is 43. Now all you have to do right here is add these two numbers together, just right across, 79, 75. And then after you're done that, you add these two together, equals 154. There you go. Simple mathematics. Now the next step is pretty simple as well. All you have to do is divide 33 by 154, 46 by 154, 32 by 154, 43 by 154. All these numbers here you divide by 154. This is what you should get after you divide everything by 154. These are the numbers you should come up with. You even divide 154 by itself, and that's how you get 1. Now the first question states, how many people did not get ID'd overall? You really have to look at the question. It's not how many males or females got ID'd, it's how many overall in total. And you just look right here, and there's your total right there. Did not get ID'd, males and females. There's your answer. Okay, the next question is pretty simple. It says, was a female required ID? And that's simple. You just look, a female that required ID, 0.299, and there's your answer. Know that both these are independent events. That means event A and B are said to be independent if and only if the probability of A is not influenced by the occurrence of B or vice versa. So neither of these ones affect each other, so they are independent. So given that, this is going to be the formula. The probability of A and B equals probability of A times B. So this is what you have to do. For this is P given A and B, you have to divide probability of A and B right here, divide it by probability of B. Now when you divide both of those, your final answer should be 0.507. And the way I got that is, as you see, I took the probability of A and B and divided it by the probability of B, and that's how I got the final product. And that, ladies and gentlemen, is how it's done.
This is example 1 for Unit 3.
For the last tutorial, we're going to show you how to do large and small sample testing. The reason these questions are tough is because you have 7 different options for what type of questions you want, and then you have to figure out if it's hypothesis testing or confidence interval testing. The easiest way we found to do these is doing them in a very slow step-by-step fashion.
The first step to doing these questions is figuring out if the sample number is large or small. This is one of the easiest parts, and it narrows down the questions, and it narrows down your options to 4 types of questions for a large sample and 3 types of questions for small sample. If the sample number is smaller than 30, it is a small sample question. But if the sample number is equal to or bigger to 30, it is a large sample question.
As I said before, small sample questions are always smaller than 30. There are 3 types of small sample questions that you can have. There are some that have one mean or average. There are some that compare the difference between 2 means or averages. And there are matched t-tests, the difference between 2 means where the groups are not independent. After you choose which of the 3 it is, you then want to choose if it is a hypothesis test or confidence interval test. The easiest way to figure out if it is a hypothesis testing question or a confidence interval question is to look for keywords in the problem. When it is a hypothesis testing question, the question will be asking for evidence and will often have the word evidence in it. If it is a confidence interval question, the question will be asking for the range between 2 numbers, and the word range is often used. I will now do an example to help you understand. Now for that example. The question reads, 2 groups of corrupt students meet to discuss their bribery strategies for a particular prof. 8 of them have been appealing to his vanity, plying him with suits and John Lobb shoes. They have an average of 52.7 and a standard deviation of 0.89. 6 of them have been getting to him through his vices, providing Cuban cigars, expensive gin, and prescription painkillers. They have an average of 54.1 with a standard deviation of 1.4. Is there evidence of a difference in their approaches at the alpha equals 0.02 level of significance? There are 3 types of questions that you have to ask yourself for any small sample or large sample hypothesis question. First, you need to figure out if it is a large sample or a small sample. Question. Since you're looking at samples as small as 8 and 6 in the question, and they are smaller than 30, you know it is a small sample question. Second, you need to look at what type of the 3 types of small sample questions it is. Since you are comparing the difference between 2 means, you know it is the second type of small sample questions. Finally, you need to figure out if it's a hypothesis test question or a confidence interval question. Since you see the word evidence in the question, and you're trying to find the evidence that there is a difference, you know that it will be a hypothesis testing question. The toughest part about small and large sampling questions is figuring out what type of questions they are. After you figure it out, you just need to look at the formulas and follow the steps whether it is a hypothesis testing question or confidence interval. After you have that, you will be able to finish the question and get 100% on the test.
Now on to an example of a large sample question, when n is greater than or equal to 30. Unlike small sample testing questions, there are 4 options. The first being 1 mean or average, difference between 2 means or averages, 1 proportion, or difference between 2 proportions. After you choose which of the 4 question type it is, you want to choose if this is a hypothesis testing or a confidence interval. The easiest way to figure this out is there will often talk about hypothesis testing in a hypothesis testing question, or in confidence interval question is to look for keywords. When in the hypothesis testing question, the question will be asking for evidence. If it is a confidence interval question, the question will be asking for the range between 2 numbers, and the word range will be in the question. The question reads, regardless of age, about 20% of Canadian adults participate in fitness activities at least twice a week. However, these fitness activities change as people get older, and occasionally participants become non-participants as they age. In a local survey of 100 adults over 40 years old, a total of 15 indicated that they participated in a fitness activity at least twice a week. Does this data indicate that a 0.1 level of significance, that the participation rate of adults over 40 is significantly less than the 20% of Canadian adults? Okay, so with every question you have to ask these 3 questions. Is it a large sample or a small sample? So the number is over 30, which is 100, so it is a large sample. what type of large or small. We know it's a proportion. And if it's a hypothesis testing or a confidence variable. It's a hypothesis testing because even though it doesn't say evidence in the question, it wants the data to be indicated at a 0.1 level of significance, at a participation, which indicates evidence. So now that you've figured out what kind of question it is, you know it's a proportion and that it's a large sample hypothesis testing, you can basically plug into the numbers into your formula, and it's as easy as that. Simple math, simple calculations, and you're good to go. So there you have it. Each unit of Stat 100. A little bit of the tougher questions that we encountered while doing our Stat 100 class.
If you follow this video and watch it over and over, you are guaranteed, I repeat, guaranteed to get 100% in your Stats 100 class.
Thanks for watching.
And have a good night and good Christmas.